welcome to your 9.1 notes on dilations. In 9.0, we've been working on reviewing some of the basic transformations that you studied previous to this class, one of which was translations, and we're going to refer to that a little bit. But a dilation is a different kind of transformation where we either stretch or shrink a figure. So you'll see the note there. It says, in general, if we take the word dilation out of context, then it means to make larger. But in math, it could mean to make larger or to make smaller. Another vocabulary word to be aware of is the center of dilation. This is a fixed point that the entire figure is dilated about. Okay, so for our purposes, we are going to be using the origin as our center of dilation. And that's going to keep things a lot simpler for us, okay? But it does not have to be. A center of dilation could be another point. So in this figure above, my center of dilation is actually this point right here, which is not at the center. This complicates things a little bit, so we're going to stick to using our center of dilation only at the origin. All right, let's talk about dilation. We have this notation, capital D, and then I have a subscript of n comma c, where n is the scale factor or the factor, and c is the center for dilation. For our purposes, because we're going to be using the center of dilation at the origin, we're just going to be seeing things like capital D and then subscript n. Each length in the image is n times the corresponding length in the pre-image. So imagine that you have a small figure and you multiply the whole thing by 5. That means that every shorter length times 5 is going to give you the length in the image. Now that's true if it's an enlargement. So the next bullet point says that when n is greater than 1, the dilation is an enlargement. So if I take every pre-image length and I multiply by 5, then I get a larger image, a larger result. If I multiply by a number that's between 0 and 1, like a half, if I take side lengths and I multiply by a half, then you can imagine that that's going to get smaller. That's going to be reduced. This last bullet point says every angle in the image is congruent to the corresponding angle in the pre-image. So I am going to go ahead and I'm going to give this figure up here letters. So let's say for my orange larger triangle here, my vertices are KLM. That would mean that for my image, I would have K prime, L prime, and M prime. Now a note, let's go back and check this out. We go back and look at 9.0, and this very at the top right here that you see highlighted, the original figure is called the pre-image, like ABC. The figure after the transformation is called the image, A prime, B prime, C prime. Now you'll see these little marks here. They look like little ones or something. They're just apostrophes, okay? So A apostrophe, B apostrophe, C apostrophe, but we call that prime. All right, so over the image has these prime marks. All right, so that means that this is the image, and the larger one would be the pre-image. So corresponding angles are going to be congruent. So if I look at M and M prime, even though the triangles are different sizes, those angles have the same measurement. If I look at angle L and angle L prime, those degrees of those angles are the same. Then we move on to a very important concept called scale factor. Scale factor is the ratio of the size of two similar figures. Now, a reminder, ratio means simplified fraction. And for scale factor, we will compare the image to the pre-image. So we will put the length from the image on top and the length from the pre-image on bottom. Example 1. Find the scale factor of the image to the pre-image for the similar figures, then find the length of the variable indicated. So in each of these pictures, I've got some lengths that are known, and I've got one length that is indicated by a variable. For example A, I have an x on C prime D prime, and for example B, I have the entire base of the large triangle as y. So the first thing I'm going to do is I'm going to work on the scale factor. For the scale factor, I need two corresponding lengths. For the image to the pre-image. All right, let's mark these. We said that the pre-image is the one without the prime mark, so this is the pre-image. Right? And then the one with the prime marks is the image. That's the new one. Just to be very clear here. I'm looking for two corresponding sides to use for my scale factor. I've got x and 5. Those are corresponding, but they're not both numbers. So I'm going to use these sides right here that are corresponding. So the image goes on top and the pre-image goes on bottom, like we said above. And then I simplify because I need a reduced fraction, right? Simplified fraction. What goes into 6 and 10? 2 goes in here 3 times and 2 goes into here 5 times. So my scale factor is going to be 3 over 5. Now check it out. 3/5 is less than 1. So notice how the image is smaller than the pre-image, and 3/5 is smaller than 1. That works out. Now for the next part of this, we're actually going to use this note below when it talks about solving proportions using the cross product property. So throwing it back a ways here. You may remember when I have a fraction equals a fraction, we call that a proportion. And to solve it, I crisscross multiply. So A times D equals B times C, right? I'm going to use that, but I have to set up my own proportion. So I'm going to have a fraction equals a fraction. Now I'm going to use my known pair. So I've got 6 and 10 already. And then I want to use my unknown pair. So I've also got 5 and x that are corresponding, right? Now, it is absolutely essential that you put the correct one on top. What always goes on top? The image. So this is going to be x over 5. So you may want to pause this for a few seconds just to make sure you completely understand this setup. 6 divided by 10 is equal to x divided by 5. If one of those fractions is flipped, is a reciprocal, it will not give you the right answer. So I have corresponding sides over each other. Right? 6 is to 10 as x is to 5. And then I'm going to crisscross multiply. When I'm solving the proportion, remember that this is a product. I'm looking for multiplication. So I'm going to go real slow here. This is 6 times 5. And then x times 10. So if 30 is equal to 10x, when I solve for x, I get 10 is equal to 3. Now, x is 3 and scale factor of 3/5. That's not necessarily always going to happen. It's a coincidence in this case. Those are the two pieces of information. Find the scale factor, boom, and find the length of the variable indicated. Got it. For problem B, the similar figures might be a little harder to see. So the pre-image is going to be the small triangle, and the original image is going to be, or the image is going to be this large triangle. I definitely recommend redrawing these two triangles here because you have kind of one embedded in the other, and it's going to be easy to kind of lose measurements. So my advice is redraw these triangles. And they don't have to be perfect. You can just get an idea here. Right, so I've got 3.5 as my height for my small one and 6 is my base. And then for my large triangle, I have 7 as my height and I have y as my base. Okay, which one is the pre-image? Let's see, this is the pre-image. And this one's the image. So when I set up my scale factor, I want corresponding lengths. Now, yes, 6 and y are corresponding, but for my scale factor, I have to have two numbers. So my options are going to be 3.5 and 7. Which one has to go on top? The image. So I have to have 7 over 3.5. Now we never, ever, ever leave a decimal in a fraction. That's not a simplified fraction. So I do have to simplify this. And you can play with this a lot of different ways. There's a lot of different ways to work with this fraction. I'm not sure, what way your elementary teacher taught you. For me, I'm pretty good at recognizing these things. So I know 3.5 goes into 7 2 times. So I could just say my scale factor is 2 to 1. If for you, if it's better to maybe multiply everything by 10 and then reduce, you could do that. That might be helpful for you. All right. Then so my scale factor is 2 to 1, and I'm going to set up a proportion to find my missing side. So the image is going to go on top. So I'm going to write a 7. And what side length does that correspond to? In my pre-image, 3.5. And then I go back to my image. And y corresponds to 6 in my pre-image. Setting up the proportion is the most important part of this problem. So pause and check it out. Make sure it makes sense to you. Again, if you were to take the reciprocal of one of these fractions, if you had like written the top on the bottom and the bottom on the top, it would give you the wrong answer. Okay, so once I have my perfectly set up proportion, I'm going to use the cross product property to multiply. So 7 times 6 gives me 42. Make sure you're multiplying. And then 3.5 times y gives me 3.5y. divide by 3.5. Most of us learn to move the decimal place when we're going to divide. So if I move the decimal place over once, multiply everything by 10. 35 goes into 42 once. 1 times 35 is 35. I subtract, I get 7, bring down the 0. 35 goes into 70 2 times. So I get y is equal to 12. Now, there are slightly different ways you can use these proportions. You could use the scale factor instead of using 7 to 3.5. If that's comfortable for you, you might be able to tell what the number is without setting up a proportion, if that's comfortable for you. This is how I would teach it from beginning to end. Now, in example 2, these are just some proportions to practice solving. So I'm going to work through A and B, and then I'm going to ask that you pause and try to do C on your own before you check your answer. So I have a proportion. A is 7 over x equals 21 over x. I'm going to cross multiply, use the cross product property. 7 times x is 7x. 21 times x is 21x. Sometimes people get stumped here. Remember, you want to put all of your x's on one side. I have x's on both sides, so I'm going to subtract my smaller x. I get 0 is equal to 14x. All right, 14 times x. How do I get x by itself? Divide by 14. What is 0 divided by 14? 0. It's not no solution. It's not cannot find. It is 0. 0, the value of 0 is what makes that true. Problem B. So I'm going to crisscross multiply. There is a hint that I would like you to write down. A reminder. When you're multiplying expressions, right? Expressions is any time that I'm like adding or subtracting something to the variable, like x plus 2 in this case. It's really important that you write them in parentheses. So I'm going to go slow on this problem. When I start doing my crisscross multiply, I have 3 times 5 equals 7 times x plus 2. It is vital that you multiply 7 times the entire expression x plus 2. So in order to do that, we're going to write x plus 2 in parentheses. 3 times 5 is 15. 7 times x plus 2, 7 times x, plus 7 times 2. Solve for x, so I'm going to move the 14, which becomes 1 equals 7x. I want to get x by itself, so I divide by 7, and I have x is equal to 1/7. I know it's like not a number that you really want to see, but 1 over 7 is perfectly acceptable. So I'm going to ask that you pause this video, give C a try before you listen for my explanation. All right. So answer for C. I'm going to crisscross multiply here. Come on, there we go. And I'm going to make sure I add and include parentheses. So I have 4 times x minus 3 is equal to 5 times 8. And I distribute 4 times x minus 4 times 3. And then 5 times 8 gives me 40. So I distribute that through. Add 12 to both sides. Divide by 4. 4 goes into 5 one time. 1 times 4 is 4. 4 goes into 12 3 times evenly. So I get x is equal to 13. Hopefully you got the same thing. If not, pause this video, go back, follow my steps, and make sure that they make sense for you. All right, next type of problem. Notation for dilation. E subscript 3 of triangle ABC means the image of the triangle ABC after a dilation centered at the origin with a scale factor of 3. Read that to yourself again. So D, capital D means a dilation. Subscript 3 means I have a scale factor of 3. Because there's no other information in my subscript, that means it's a dilation at the origin. So example 3, given triangle ABC, what are the coordinates of the vertices for a dilation of 3 for triangle ABC at the origin? Draw the image. Okay, so I'm going to use my figure here to find the vertices of this triangle. So A is the point 1, negative 1. B is the point negative 1, 2. C is the point 2, 0. And what I'm going to do to create a dilation at the center is I'm going to multiply each coordinate by 3. So I get a new point. I get the image. Instead of 1 and negative 1, I have 1 times 3, negative 1 times 3. Right? So I'm just going to write a little asterisk here. Multiply x and y by 3. That gives me a new point. A prime, which is over 3 down 3. And I do the same thing for the next point. So a dilation of 3 means that my new point B prime will be negative 1 times 3 is negative 3. 2 times 3 is 6. So B prime is negative 3 up 6. So B prime is now negative 3 comma 6. And we do D. I'm sorry, C. So the pre-image is at 2, 0. I'm going to multiply both coordinates by 3. So 2 times 3 gives me 6. 0 times 3 gives me 0. So 6, 0 is going to be C prime. Now this may not turn out really clear, but now you want to draw the triangle. So I need to connect A prime, B prime, and C prime. I'm going to do the best I can on this device. Whoop. Nope, let's try again. All right, the shorter ones will be easier. If you're doing this on paper, I highly urge you to use a ruler, straight edge of some sort. All right, should look about like that. So hopefully you can kind of visualize a little bit in your head that that larger triangle is 3 times the size as the smaller triangle. Each length, each corresponding length is 3 times as long. So if I get into it even a little bit further with you, right, you'll notice AC right here, right, that's up 1 over 1. Well, A prime C prime is up 1 over 1, up 1 over 1, up 1 over 1. So that's actually up 3 over 3, right? It's 3 times as long. Example 4 is the same type of problem. Now I have a large triangle with a dilation of 1/4. Since that dilation is smaller than 1, my image is going to be smaller than the pre-image. So we start the same way. I'm going to find the coordinates of P, Q, and R. All right. Now, when I take that dilation of 1/4, that means I'm multiplying each coordinate by 1, or each part of each coordinate by 1/4. So P prime, now I have 8 times 1/4, which is 2. And I have 4 times 1/4, which is 1. So a dilation of 1/4. For Q, I have 12 times 1/4. Hopefully you can recognize that multiplying by 1/4 is the same as dividing by 4. It gives me 3 comma, and then negative 1/4 times, I'm sorry, negative 4 times 1/4 gives me a negative 1. And R prime is going to become 1/4 of negative 4 is negative 1. 1/4 of 0 is 0. All right. So I plot these points. 2, 1 is P prime. Q prime is 3, negative 1. And then R is prime, negative 1, 0. This one's a lot easier to draw because the triangle's small. Points are closer together. Okay, now while it would take either a ruler or using the distance formula to find the actual length of these, I can kind of use my tools to kind of talk about the length, right? So if I was given the picture only and I wanted to find the lengths of these, I could compare them by, well, for example, let's see, this PQ right here, right? This one that I'm trying to highlight is from P to Q is down 2 over 1. And if I do that here, I go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So I can tell that it's 4 times the length. Kind of makes sense, hopefully. Okay. And then the last one, example 5, is very similar to 3 and 4, but there's no image to work with. So I'm just going to do, I'm just going to work with the numbers here to find the coordinates of the image. So I would ask that you pause this video and give it a try. So I've got triangle XYZ. So X is -5, 6. Y is 1, -2. And then Z is -3, -4. And we are doing a dilation of times 4. So go ahead and find all 3 of the new coordinates. Pause the video, find the new coordinates, and then you can check your work. All right. So when I get my new coordinates here, remember this is x prime, that's an apostrophe, so I multiply everything by 4. So -5 times 4 gives me -20. 6 times 4 gives me 24. One times 4 is 4. -2 times 4 is -8. And then -3 times 4 is -12. -4 times 4 is -16. So the problem here just asks what are the coordinates of the vertices of a dilation x of triangle XYZ. So those are my new points. Okay, that wraps it up for the 9.1 notes. Thank you very much. Have a good day.